So welcome everyone to the sessions of programming in Python. We would be resuming the session where we left in the last class. To give a quick revision, we had learned a basics about what a series is, what a pandas are, what a data frames are in pandas. So basically they are the new data structures introduced by the framework pandas. And a data frame looks like a tabular kind of data structure which has row headers and it has column headers. And we have learned how to convert an existing data structure like a list of dictionaries or a list of lists into a data frame. And we also learned how to read Excel or read CSV uh, into Python environment using Pandas. So to give a quick revision, if I write data underscore df, so this is a variable that we're creating and we're going to store our data frame in it. I'm going to write pandas, say import pandas, and I'm going to write data underscore df equal to pandas dot read Excel. Okay, and within it I am supposed to give a file name. For example, if my file name is student.xlsx, remember that this file is supposed to be at the same location. Okay, if it is CSV, then I'm going to write the CSV file name here, but remember that even the function name shall be changing. Okay, so I'll write here CSV. And if I were to show you, you can see that here there are a lot many functions. You can see here, read Excel, read CSV, read HTML, clipboard, feather, pickle, SQL table, SQL query. There are a lot, XML. There are a lot of functions to read different kinds of files. Okay, so why do we have these functions? Because if you want to import your data from some external source like a file, so you can read that CSV or an Excel file in this manner, and you can have the data stored in, have the data read and converted to data frame and maintain the data frame in this particular variable. Okay, and thereafter do the regular procedures, whether you want to clean the data, whether you want to analyze the data, process the data, or visualize data, whatever. Okay, but for this particular instance, I am going to create one data frame, data myself. Okay, so this is my data. At present, it is a list of dictionaries. Sorry, it's a dictionary which has values as a list. Okay, so the keys happens to be name, age, and country, in which the values happens to be the equal length lists. Okay, so if I want to convert this into data frame, as you can see, if I print it directly as it is, you would see the same value here. But if I convert into data frame, so maybe I'll write it df. So df is a short form. It's my variable name, and conveniently I've just given it 2 letters name, and I will write pandas dot data frame. Okay, and within this I'm going to write data here. Okay, and if I print here df like this, you will see that the data frame has been created for you and has been converted, right, from dictionary. Now it is in the form of a data frame, right? Okay, in the last class we were learning lock, right? So let me also create one more column called as score. Okay, it begins 50, 100, 142, 65. Okay, so if I run this, short moment, I think the kernel stopped. Now if I try to print the df, you can see that all the 4 columns are there, right? Now, like I told you, just to revise, if I want to access only the complete data frame, then I'm going to write like this. But if I have to filter it by just age, then I'm going to just give the age column here within the square brackets, and it is going to give me age. If I have to give multiple like age, score, then remember that this is becoming a collection of data, right? So I will have to encompass that within a additional list. So like this, I will be giving. If I run this, you can see that 2 columns have been filtered, isn't it? This process of filtration, we can also carry out using lock method. I can write here filtered underscore data. And I can write here df dot lock square brackets. Remember, it's square brackets. And now I have to give certain indications which can help Python to select what rows and it can help select what columns. Okay. So let me tell you here that you can see here that at the moment it is default 0, 1, 2, 3. These are the row headers, right? So I can tell I want 0th row, I want 2nd row, okay, and I want 3rd row. All right. And when it comes to columns, I can tell here that I want name and I want country, okay, like this. So if I run this, let me try to print out the filter data here. You can see that the data has been filtered for you, right? Now this filtration is working with respect to what rows and what columns that you want to select. So you have explained by yourself, right? You have listed down the rows, you have listed down the columns, and you are selecting them. But suppose you want to give conditions. For example, I want only those data in which the age is greater than 25. Okay, so what I'm going to do is remember that columns is just for visibility. Okay, columns is just for visibility. Let me put a colon here. Colon means all the columns will be selected. And when it comes to rows, let me tell that df age. Okay, so this is pointing towards single column, right? And I can tell you that this has to be greater than 25. So all the data rows in which age is greater than 25 shall be selected and all the columns will be selected. So you can see here that 28 and 30 have been selected for you, right? So this is how the filtering works. One more thing I want to tell you is in Python, you would have come across the keyword and or, right? Like we say, if it's raining or it's night, do not step out. And you can also say if it's sunny and if it's weekend, you can go out and play, right? So the and or, these keywords are used to assert whether you want both the conditions to be true or all the conditions to be true, or you are okay with either of them being true, right? So this is where. So in lock, like I told you, you're giving indications for row and columns. If you want to if you have multiple columns, if you have multiple conditions for the rows to be selected, then that also you can give. For example, if you want the age should be greater than 25 and score has to be greater than 100. So maybe I can write here age has to be greater than or equal to 20. Okay, greater than or equal to 25. And in pandas, it is not and we write, but in pandas the equivalent of that is this and equivalent of or is this symbol. Okay, so here I'm going to write and, okay, let me put parentheses here so that our conditions are clear. So this is one condition, and the same thing I can write, copy paste here and adapt it to contain score. The score has to be greater than or equal to 17. Okay, so here you can see that, and I just want to see, suppose I just want to see name, okay, name of these candidates for satisfying my condition, right? So you can see here that in the lock, this is indicating towards row, this is indicating towards column. And if I run this, you will see that it says Sarah. Sarah is the only person whose age is greater than or equal to 25 and whose score is greater than or equal to 70, right? So for this condition, you're getting the name. If I reduce the condition criteria here, say 40, if I do, let's see, I get so many. I get John, Sarah, and Jessica. Correct? So this is about lock and about lock. In lock, you give the actual headers here to either put the filtration in rows or put the filtration in columns. You have another method called as ilock. Ilock means integer lookup. Okay, remember that 99% lock and ilock are same. The only difference is instead of the actual headers like name, score, age, you give numerical headers. See, every if a custom header is not given to any data frame, then by default it takes numerical headers, right? Zeroth row, first row, second row, correct? So even if the custom headers are being given, then also all the columns have these underlying numerical headers and underlying row headers. So the columns can also be referred as zeroth column, first column, second column, and even the rows can be referred to as zeroth column, first zeroth row, first row, second row. So when I am talking about ilock, then at that time I start dealing with integer kind of, I start referring my rows and columns with integers. For example, I can say here 0, 1, okay, and it comes to column, I can say second column. I run this, I get this, correct? If I say only zeroth row I want, but I want column to be second and third in this sequence, you can see here. If I want 0 to 5, I can give like this. Make sense? So this is how the lock and ilock works together. Okay. So this is about filtering. Okay. So here somewhere up we have written that we take the input, we convert it to data frame, we filter it out. Now let's learn what cleaning the data means. When I say cleaning, remember that suppose there are some uh, NaN values or empty values. For example, if I'm importing NumPy, and here I can write numpy.nan. Okay. If you're wondering what this numpy.nan is, imagine that if you are reading an Excel, and in that Excel, if there are certain empty cells, okay, there are certain cells which do not have any data, they're just empty. So when you try to read them and print it here, instead of those blanks, you're going to get nan. Okay. So that nan, if you want to hardcode here, you can always write numpy.nan. Okay. So I'm going to give at multiple places numpy.nan. And now if I try to run it here, if I try to print df here and run it, you can see that you have nan here and you have nan here, right? So this is called as not a number, empty values. This is very small data set, but when you work in corporates or when you work on larger projects, whether it is academic project or research project, or when you're working on any corporate project, the data sets are very huge. For example, the banking data, there are so many transactions happening every day. There is going to be data about who the sender was, who the depositor was, how much amount sent, from which place to which place, from which bank to which bank, etc. Right? So many data points are there. In a similar way, if you're dealing with the customer data, for somewhere a data which is coming from some customer service, that also has a lot of data points, right? In that case, cleaning the data becomes very essential, because analyzing such kind of data where empty values are there, it is not feasible, right? So how can I clean the data? The very first thing I can do is I can drop this data here, and I can drop this row itself, and I can drop this row also from the whole data frame. How do I do that? So drop NA. NA could say not applicables. Okay. So I am saying df dot drop NA. So this, like I said, df is a data frame object. In this object, there is a method called as drop NA. When I invoke that method, it gives me back of data frame which do not have these empty values. So if I run this, you can see that all my empty values has been removed. They have been dropped from data frame, right? So this is one style. So what I'm doing is I'm dropping in the new data frame that is being given back to me. I'm storing it here, right? If I don't want to store it here like this, and what I want is the moment I invoke This drop should happen at the source itself. It should happen here itself. So I have the privilege to write in place equal to true. So this parameter you can set as true. What will happen is it will modify the original dataset itself, something like this. Okay. In case you don't want to write like this, then you have to ensure that the new data frame is as well stored, right? Okay. This is one way to clean your data. The other way could be, suppose you don't want to drop the data, those data rows. Maybe the data is sensitive, you don't want to drop it. Then what you can do is you can fill it with some alternate values. So instead of drop NA, I can say fill NA. So what do you mean fill NA? I can say fill with 100, okay? And you can see here that the NaN values have been substituted by 100. If I write 500, they have been substituted by 500, right? If I write 0, then they shall be substituted with zeros, right? So in that case, we are not losing at least on the data. We are not losing on the rows. So this is how you can do. Okay, this is how you call it cleaning the data. Okay. Now, if you have to look at other methods, the another method that you can think is maybe you want the top. Okay, let me put here some valid values. Maybe I can put here 50 and I can put here 120. Okay, uh, I want to modify the data. Okay, so we have crossed this stage. We have cleaned the data. Now the time is to process the data. What I mean by processing the data, it means if I want to alter the data. So this is my data at the moment, right? If I want to multiply this age by 100, then what can I do? I'm going to write data age, and here I'm going to write data age multiplied by 100. So what I'm doing here is I am accessing one column. In that column, I am substituting a new column, and that new column is built by that column multiplied by 100. That means each value shall be multiplied by 100 and substituted. So if I run this, you can see that. Okay. Just a second. Okay, I should have converted this into data frame first. Okay, now let me modify the data frame. As you can see that I'm updating my variable in here. Look at this. All the age have been scaled up, right? So this is one way. Now suppose you want to add something here. USA nation, Canada nation, Australia nation. So what I can do here is I can do the similar stuff with country. I can plus and I can concatenate something like space nation. Okay. If I run this, there's some error here. Yeah. As you can see here that I have modified the complete column, right? Yeah. Suppose I want to add another column, then what I can do is I can write here the same data frame and I can write here maybe whether it's a pin code. Okay, maybe I can write pin code of the candidate. So here I can write a list. I can provide maybe this is one pin code. This is another one. This is another one. This is another one. Okay, how many values do we have? We have just 4, right? So let me stick to 4 values. It's going to be the comma. Okay, if I run this, you can see that another column has been added. So this is way to add the column. This means that whatever is on the right side should be substituted here. However, pin code doesn't exist, so it has been created for you. Okay, right? Now, suppose you want to apply some function over it. For example, instead of score, I want to create another, let me create another column here called as score square. Okay. And initially I'm going to store 0 to all the values. Okay. So you can see that one more column has been created, score square. You So you can see that this column has all zeros, right? And now I want to apply some function. That means I have a way here that to this I'm going to write score multiplied by 2. Multiplied by, this is exponential. Okay. Now let's see how data underscore df is getting formed up. You can see that. Let me not print this one to avoid the confusion. Yep, you can see that this is how the exponential is working, right? Or if I write 0.5, yeah, you see here, I considered these columns and corresponding columns I computed, and the computed value I'm storing it here. So this also works. Okay. Suppose I want to, in pin code, I just want to consider first 3 characters. Then there is something called as, suppose I am creating a function here, define curtail values. Okay, this is my own function. And whatever the value comes in this, I'm going to return the data 0 to 3. Okay. So in this data frame, I'm going to write here, let me put pin code here rather, dot apply. Okay. The apply method, what it does is on any column, it is going to apply some feature. So maybe I can write this particular function name here. So apply this. So you are applying this particular function over this whole column. What this function does, whatever value it is going to return on the first 3 elements. So if I run this, you will see that that function, that custom created function got applied there. So if I run this, some error here, object is not subscriptable, int object. Okay, maybe I should convert that into integer, because first I'll have to convert that into string data. Why I'm converting that into string? Because only strings are subscriptable. If I run this, you will see that the new pin code here got updated to only 3 characters, right? So any columns you can modify like this. So the whole point to show you these so many methods is because once you have created a pandas data frame, you can do so much of data analytics. You can pre-process, you can read the data, you can analyze the data, you can filter the data, you can also modify the data. So this is coming under modification. All right. Yep. So going forward now, the next thing that we're going to learn about here is bit of outputting the data. So suppose this is my data here, which I want to output it out. Okay, so this is, you can see that this is a modified data, right? I want to put it back into, say, CSV or Excel. What I can do here is, this is my data frame object. I already know there is a method called as to CSV in case I want to output it as CSV. Okay, so if I want to write output dot CSV, then and I run this, then let me go back. Um, let me go back to, to the place where we were doing. You can see here that this is where my Jupyter notebook is launched, and you can see that output.csv has come up. How? It's because all the data that I'm maintaining in a data frame object, it got published here. So if I output this, if I open this output, you can see that the whole output has been put in this CSV file. You can see that even the row headers are coming. Suppose you don't want these row headers, what you can do is you can always write here index equal to false. And yeah, I should ensure that the Excel is already closed, otherwise it's going to throw an error. Yep. So it's run. Now let me open it again. And you can see here that row headers are vanished and this is coming like this, right? In CSV file. In case I want to output it in the form of an Excel, then I should be using two Excel function like this. Okay. And here also I should get proper format Excel SX. Okay. Like this. Let me check here. Yep. Here you can see that output.xlx has been generated. If I open this, and you can see here, right? If you're wondering how this can be useful to you, then please remember that when you're programming, there would be a lot of times when you might be holding your data in a dictionary or in a data frame. Then remember that if you want to output and maintain your data in such kind of files, you can always publish such files. Okay, it's very easy to do using Python's Pandas framework. All right. Okay. Now, now let me try to show you another one. Okay. So all this while we have learned how to create the data frame, how to analyze the data frame, how to output the data frame, how to filter the data frame. Now let's also learn the basic statistics that we can do on data frame. So suppose this data.df is my data frame. If I want to do the basic statistics, maybe I can take dot mean. Okay, so let me print it. You can do this on the whole data frame, or you can also do it on the single column. So you can see that for these columns, these are the mean. Just like mean, if I want to write median, then you can see that these are the median values. Okay, and just like median, if you say mode, you get the mode. Okay, and just like median mode, you can write variance, you get the variance here. Okay, and if you write STD, that means the standard deviations. Okay, so all such analysis you can always figure out. Okay, and if I say count, it can tell you that in each columns how many values are there. And if I say count underscore values, then this tells you how many unique values are there. Okay, okay. This has some, if I, we are making a slight mistake here. Yep. Okay, so basically value and count, this actually tells you that how many unique values are there. Okay, if I tell with respect to single column, maybe country, just country here, and you're going to see in this particular column how many unique values. So value counts is unique value counts. Okay, so everything is one. But tomorrow if I change that to, let me change the data here, let me put to USA. Okay, And you can see here that USA is occurring 2 times, right? Okay. So this was a basic sneak peek into how even computations can also be done on Pandas data frame. You have seen how a filtering can be done, how the processing could be done, how each columns could be modified, etc. Isn't it? Now, the last part into the Pandas that we have is actually towards the visualization. So let me show you how uh, this is the flow, right? You input the data. That means somehow you create the data frame. You either read or you create or you convert, then you filter it out as per your needs. You might not want to see all the columns, all the rows. You filter appropriately. You clean the data. You drop unnecessary data, all the empty rows. You process the data. In case you want to process any single column, you can do that. You have also seen how you can output into CSV or Excel. Now let's see what I mean by visualization. Okay. So when I say visualization, it means Pandas also works in in a consonance with matplotlib, and you can also visualize your output here. Okay, so let's see how do we visualize. So if this is something that I have, this is the data frame that I have. Let me print how this data frame looks like. Okay, so this is my data frame, right? So you have name, you have age, and then you have country, everything, correct? I want to, if I want to visualize this, that means plot a graph out of it. First, I'm going to import matplotlib dot pyplot as plt. Okay, so I'm writing a short form here. From the matplotlib, I'm using the pyplot module and I'm importing that as plt. Okay, this is something I'm going to do. And then I already have the data frame. So now let me write here data underscore df dot plot. Okay, you can see here that age, score, and score square, all of them are being printed, right? If I want to modify it better, I can write kind equal to bar. This kind of properties also I can give. So here you can see that it's printing a bar graph for me, right? In case I want to give some header name, say x equal to x header name, okay? And similarly, if I want to give for y equal to y header name, all right? If I run this, mm, 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 okay, sorry, maybe not here. This is not the way. I mean, here you're supposed to give name, okay? That x I want to keep name, and in the y I want to plot age, or maybe I could put age against score. X and y. Your x has to be the name. So you have a column called as x, your name, and y could be your age, and kind could be your bar. Okay. And all right, yeah, there was a space in between the name. That shouldn't be the case. So you can see here that age against name has been plotted, right? So this is how you plot. If you want to give some more customization like plt.grid, you can do to plot the grid here. You can see now the grid has come up. You can also give plt.titles if you want to give a title to your graph, something like mm, this is a sample graph. So you can see that this is a sample graph, right? And in the if I write here scatter, This is a kind of a scatter graph. If I write line, you're going to get a line graph. If I write here bar, then I'm going to get a bar graph. If I write here area, then I'm going to get the area graph. If I write hist, then I'm going to get the histogram here. So all these are some properties which you can utilize to plot the graph. All right. So you can see that going forward, if you are utilizing Pandas, Pandas is a very helpful library. You can handle a lot of data together. Unlike NumPy, Pandas can store the data of different types. You can read the data from different sources quickly, like Excel or CSV. You can process it. You can output your results into an Excel or CSV, and you can also visualize your outputs like this. Okay, apart from analyzing, and of course the wonderful filtering facilities. So for all such data analytics, we use Pandas. Okay, right. So this was the basics of Pandas. I would say please practice it, and any doubts, just reach out to me so that I can clarify. And I would be sharing some practice and assignment questions. Just walk through it post listening to this session. Thank you.